Hello, welcome to Chapter 2. We finished Chapter 1. Hopefully this flipped classroom is going well for you. And if you're from some of my other classes, hopefully you are using these videos and that they're helping you become a little more successful. So we're going to start Chapter 2, and we're going to start by talking about this word that is called polynomial functions. Polynomial functions. Polynomials. So Section 1 is called Zeros and Factors of Polynomial Functions. And the objective of this particular section is to identify polynomial functions and to evaluate them using synthetic division. So those are the two main functions that this particular section is going to cover. So moving on, a polynomial. Okay, so we're talking about this word polynomial is an expression. Expression meaning that it does not have a what? An expression does no equal sign. Okay, so we're talking about something that has no equal sign. Okay, and an example of a polynomial would be 6x to the fifth plus 5x to the third minus 4x squared plus 54. There's an infinite amount of examples that we could choose. All it has to have is multiple terms. Okay, multiple terms. So we have one term. This one has one term. Let me get back on my pen. It has one term, two terms, three terms, four terms. Okay, and we'll talk more about terms in a couple minutes. So I'm going to give you another example of a polynomial expression, and then we're going to talk about some vocabulary words that you should know. Okay, so the first vocabulary word that we're going to learn is what it means to be in standard form. Okay, standard form. That means that your polynomial is written from highest exponent to the lowest. That would be the definition of a polynomial in standard form. So if we notice, it goes from 5, 4, 3, 2, 1, and 0. So this is written in standard form. Terms. A term of a polynomial is anything separated by a plus or minus sign. So anything separated by a plus or minus sign. So how many terms does this have? It has 1, 2, 3, 4, 5, and 6 terms. So this one has 6 terms. Okay, so that's the first two words you need to know: standard form and terms. Moving on, so we have the exact same polynomial expression. Now we're going to talk coefficients. Okay, coefficients are numbers in front of variables. And this should all be reviewed. You did all of this in Algebra 1, but we do need to recap and make sure that you are understanding these vocabulary words before we use them. So what are the coefficients for this particular polynomial? So we have 6. Then we have 7. Then we have -6. Then we have pi. Then we have 2.7. And then do I need to write a -6 again? Should I write -6 twice? No. So the coefficients are 6, -6, 7, -6, pi, 2.7. The numbers in front of the variables. Okay. The fourth term is called the leading coefficient, and that would be the number in front of the highest exponent. The number in front of the highest exponent. So what would be the leading coefficient here? The biggest exponent is 5, so my leading coefficient is 6. Okay, so my leading coefficient is 6. Number 5, what is the leading term? It would be the term with the highest exponent. It is the term, oops, spelled that wrong, let me get rid of that. It is the term with the highest exponent. So for this one, the highest exponent is 5, so you take the whole term, and that is your leading term. So 6x to the fifth is your leading term. And lastly, the degree. The degree is, let me get a pen back, the degree is the highest exponent. So this particular polynomial expression has a degree of 5. The highest exponent is 5, so it has a degree 5. Okay, so those are the vocabulary words you need to know for polynomial expressions. Okay, so we got a little chart here. We're going to talk about degree again. Each particular degree has a name, and then I'm going to show you an example. Okay, so what happens if we start with a degree 0? That is called a constant polynomial, or a constant expression. Okay, a constant expression. And an example is just any single number. 6 is an example of a constant expression. So no variables. So if you want to write, over here, no variables, that would probably be a good idea. Okay, there's no variables in a constant expression. So a degree 1 is called a monomial. A monomial. Not a monomial, a monomial. An example would be anything that has an exponent of 1. So 7x to the first. Do we need to put a 1 here? No, we do not put the 1. We just assume that there's an exponent of 1. A degree 2 is called a quadratic. This should be familiar because we just talked about quadratics. Okay, a quadratic equation. An example would be anything with a power of 2. So 6x squared minus 3x plus 2. The highest exponent is 2, so it's called a quadratic. Okay. Degree 3. Degree 3 is called a trinomial. A trinomial. And an example would be anything with a power of 3. Oops, sorry. I'm getting my names mixed up. It's not called a trinomial. Sorry. It is called a cubic function. Cubic meaning power of 3 cubed. Okay, so 7x to the third minus 3x squared would be an example of a cubic. So as long as all it has is a power of 3.
At this time, if we have first-year freshmen report to the picnic area. Thank you.
Okay, anytime it has a power of 3, sorry for that interruption, a power of 3, you know it is a cubic function. Okay, so degree 4 is called a quartic. 4 quarts make a gallon, so this is called a quartic function. So anything with a power of 4, so pi x to the fourth minus 3x cubed minus 7 would be an example of a quartic because the degree would be 4. And lastly, the last one we're going to talk about is called a degree 5. This is a quintic. Someone who has 5 children is called quintuplets. So degree 5 is called a quintic. This could be, I don't know, negative 3x to the fifth plus 7x to the fourth plus 3x minus 2. Notice you do not need to have all of the exponents. You just need to make sure it at least has a 5 to be considered a quintic. Okay? So a constant, a monomial, a quadratic, a cubic, a quartic, and a quintic. Okay? I'm actually going to slightly change this. Instead of using monomial, we're going to use linear, because that's what we used the last chapter. So at degree 1, we are going to use linear. Sorry about that. Okay, a linear expression, or a linear function. Okay, moving on. In the homework and in the section, you're going to see these 3 words: roots, zeros, factors, solutions. Okay? They are all the same. These all mean the same thing depending on the type of problem that we use. Okay? But roots, zeros, factors, solutions all basically mean the exact same thing. Okay? And we'll talk more specifically about each one when problems arise. But if you see those 3 words, it pretty much means you're talking about the exact same thing. All right, so example 1. It says find the zeros of the following function. It says find the zeros of the following function. So what that means is we are going to take the expression that they give us, f of x means function, and we're going to find the zeros. So instead of f of x, we're going to find the zeros. So instead of f of x, I'm going to put in a 0. I'm going to rewrite everything else, and we are going to solve the problem. Now, This particular problem, to find the zeros, we are going to factor. So 0 equals, now what can I take out of a 2x cubed and a negative 32x? Okay, well both are divisible by 2, and I can take 1x out of each one. Okay, so then we're going to see what we have left. Okay, if I take a 2x out of 2x cubed, I have 2x's left over. And if I take a 2 out of 32, I get 16. 32 divided by 2 is 16. And if I remove the x and I move the x, I don't have any x's left. Okay, so we need to continue on. I can keep factoring. This now turns into a double factor. What times what is x squared? Well, we have x and x. What times what is negative 16? Positive 4 and negative 4. Okay, so now we are fully factored, nothing else we can do. The only other thing we need to do, though, is to figure out what makes each of these 0. So we have 3 problems. So 2x equals 0, x plus 4 equals 0, and x minus 4 equals 0. To solve each of these, this one we divide by 2, so x equals 0 divided by 2, which is 0. This one we would subtract 4, so x equals negative 4. And we would add 4, x equals positive 4. Okay, so let's use some of our vocabulary words here. Each of these numbers are called roots. Okay, these are roots. They are also our zeros. These right here, these 3 pieces of information are our factors because this is in factored form. Okay, these are factors. Now, let's come over here and look at the graph. This is a graph. This graph right here is a graph of our original function, y equals 2x cubed. This is y equals 2x cubed minus 32x. Okay, if you notice, where does this graph cross the x-axis? Well, this one on the left is at negative 4. It's kind of hard to see, but this does cross at 0, and this one crosses at positive 4. Well, look at our answers, 0, negative 4, 4. Okay, hopefully that makes some sense. Okay, moving on, example 2. Same thing, we're going to find the zeros. So, oops, get rid of that. Okay, so we have to, instead of f of x, we're going to do 0. Okay, now, what makes fractions 0? So if we have a fraction, some number over some number, and it says it's equal to 0, what must be true about that fraction? Well, the only way to get a fraction equal to 0 is if that number on top is equal to 0. So anytime you're finding the zeros of a fraction, you take the top portion, okay, you take the top portion, and you set it equal to 0, and that is your 0. That's your 0 for this particular equation. What makes this equation 0? The top. So how do I do this? We add 1, add 1. So x equals 1 is my answer. So if we look at the graph over here, where does that graph cross the x-axis? At 1. So there is this is our root and our 0 of that particular problem. Okay. Next, example 3. Example 3. It says, if p of x is equal to 3x to the 4th minus 7x to the 3rd plus 9x plus 10, what does it equal? Okay, and it wants to know what p of 2 is. So we're going to take p, and we're going to plug 2 into our equation everywhere you see an x. So 3 times 2 to the 4th minus 7 times 2 to the 3rd minus 5 times 2 squared plus 9 times 2 plus 10. And we're going to solve all this work. 3 times 2 to the 4th is 16 minus 7 times 2 to the 3rd is 8 minus 5 times 2 squared is 4 plus 9 times 2. 9 times 2, we can do that one pretty easily. 9 times 2 is 18. Okay, so this is 18, and then we have plus 10. 3 times 16 is 48 minus 56 plus, minus, making some mistakes today, minus, what do we get? Minus 20 plus 18 plus 10. Okay, so let's see what we get here. So what is 18 plus 10 is 28. 28 take away 20 is 8. So we're done with this. This and this is all equal to 8. 48 take away 56 is negative, what do we get there? 48 take away negative 56. Let's do that on our calculator just so I'm showing you the proper way. Oops. 48 take away 56, I don't want you to think I'm doing this wrong, is negative 8. So we have negative 8 plus 8. So what is P of 2? 0. Negative 8 plus 8 is 0. Okay, so this means that 2 is a 0. Hopefully that makes sense. Oops, that's a nice circle there. That's a beautiful circle. So 2 is a 0 because what's your answer? It was 0. Now, this is a long, drawn-out process. All of these numbers, all of these exponents, all these signs, you have to make sure you do them correctly. Well, there's an easier way to do this, okay, and it's called synthetic substitution. So we're going to do the same problem. We're going to do synthetic substitution, okay? So we're still trying to find P of 2. We're doing the exact same problem. All right, so what you do is this. You take 2, you take your 2, and you put it in a box, like a half box, okay? Then what we're going to do is we're going to list all of our coefficients. Our coefficients are 3, negative 7, negative 5, 9, and 10. Okay? 4, 3, 2, 1, 0. You're going to skip a line, you're going to draw a box, and then you're going to put or a line, sorry, and then you're going to draw a box in the bottom right-hand corner. Okay, that's the setup. The number you're trying to plug in, and then your coefficients. Okay? So the first step is to drop the first number down. Then you multiply. 3 times 2 is 6. Then you add. Negative 7 plus 6 is negative 1. And then the steps repeat. Negative 1 times 2 is 2. Negative 5 plus 2 is negative 3. Negative 3 times 2 is negative 6. 9 plus negative 6 is 3. Sorry. So did something happen here? So, and the last step is to multiply again. 3 times 2 is 6. 10 plus 6 is 16. So, let me see. Let me just make sure that I'm doing the right steps here. 4, 3, 2, 1, 0. 3, negative 7, negative 5. So, first, we brought down the 3. 2 times 3 is 6. Negative 7 plus 6 is negative 1. Negative 1 times 2 is negative 2. I knew I made a mistake in there somewhere. So what I'm going to do is I'm going to start over just to make sure that I'm not making any mistakes here. I want to show you the correct way. Even I make mistakes, so hopefully you will not do the same. Okay, so same thing. Our 2 goes in the box. We use our coefficients 3, negative 7, negative 5, 9, and 10. List them. You drop down the first number. Then you multiply. 2 times 3 is 6. Negative 7 plus 6 is negative 1. Negative 1 times 2 is negative 2. There was my mistake. Negative 5 plus negative 2 is negative 7. Negative 7 times 2 is negative 14. 9 plus negative 14 is negative 5. Negative 5 times 2 is negative 10. 10 plus negative 10 is 0. Okay, now, this is a little bit quicker. The answer to your problem is always the number in the box. So just like last time, P of 2 is equal to 0. And if I go back to the last slide, what did I get? P of 2 is equal to 0. So let me show you one more example of why this is much quicker than actually doing all the substitution. Okay, so here's our example. So what we're trying to find is P of negative 3. So negative 3 goes in my box. Okay, what happened there? Let me try that again. Then my coefficients. 3. Notice this goes from 4 to 2, so I need to put a placeholder in there for the third term. Then we have negative 5, and then we have 9, and then we have 10. So if you're missing one of your exponents, you need to put in a placeholder. Okay, so let's do this. Bring down the first number, 3. 3 times negative 3 is negative 9. 0 plus negative 9 is negative 9. Negative 9 times negative 3 is 27. Negative 5 plus 27 is 22. 22 times negative 3 is negative 66. Negative 66 plus 9 is what? So for those of you who don't believe me, we have negative 66 plus 9 is equal to negative 57. Oops. Keep making stray marks here, sorry. Negative 57 goes here. Then we have negative 57 times negative 3. Negative 57 times negative 3 is equal to 171. So that goes here. 10 plus 171 is 181. So here is our answer. The answer to these are in the box. So P of negative 3 is equal to 181. That's what your answer should look like. Okay, so P of negative 3 equals 181. Okay, so that is section 1. Hopefully that makes some sense. If you need to go back and rewatch some of these parts, please do not forget to. This is called synthetic substitution. Thanks for watching. See you tomorrow.